Hi, welcome to Mistake Man. This is an instructional video on how to build your own version of my Sonic item boxes in either Papercraft version or 3D printed version. If you want to learn more about my design process and what went into creating these, I cover that in another video, and the link for that video is down in the description, so go check that out if you're curious. In this video, I'm going to focus just on the steps required to actually build one of these. All of the files that you're going to need for this design to build your own are located in a link down in the description, and I'm providing that for free to anyone who wants to build one. So go ahead and check it out. For the Papercraft version, you're going to need to print out the pattern for all of the Papercraft parts onto some gray paper like I have here. There are also some design files that you're going to need if you want to also do the lighting and create the circuitry that's controlling the blinking pattern on these. There are also some files that you can download for the 3D printed version. Plus also there's a component inside the box. So this component here that holds the screen image, the circuit board with the lighting, and then the battery, that can be 3D printed. And you'll want that whether you're doing the 3D printed of the box itself, or if you're going to do the Papercraft version, you can also use this 3D printed. I call this the board caddy. You'll want the 3D printed version of the board caddy there. Or if you don't have a 3D printer at all, then you can still build the Papercraft version, but instead of doing a 3D printed board caddy, there are plans for building that board caddy out of sheet styrene. These instructions in this video are going to start off with how to build the Papercraft box. If you're not doing the Papercraft box, you can skip ahead to other portions that you are going to need for the circuitry inside and for assembling the parts for the 3D printed box. So check out the chapter markers down below to skip to certain portions of the video. Here's a quick summary of the materials you're going to need for this project. First off, you're going to need some light gray colored cardstock. To give you an idea of about which shade of gray you're looking for, there it is against some white paper. You're also going to need some black cardstock. You're going to need some plain white copy paper. So this is not cards, it's just plain copy paper thickness. You're going to need some vellum. You'll need a sheet of clear plastic. And that could be something like this, a sheet of clear plastic made for crafting. Or if you don't have that, you might be able to find some clear plastic sheet that you can scavenge out of some product packaging like this. You're also going to need some chipboard, which is like a very thick card. If you don't have chipboard, you can scavenge something similar from product packaging. Something like this, it's made from a thick card. Really, this is just chipboard. And even if it has printing on it, that would be fine as well. So something like a cereal box would be perfect. It doesn't matter that it has print on it because we're going to use this material in a portion of the model that isn't going to be seen. I wouldn't use anything corrugated as that's likely going to be too thick for what we need. To give you an idea of the quantity you're going to need for each material, for the gray cardstock, you're going to need a minimum of 3 sheets. For the black cardstock, you'll need 1 sheet, and not really even a full sheet, just maybe about that much of one. For the plain white copy paper, you'll need a minimum of 2 sheets. For the vellum, you'll need a minimum of 1 sheet. For the clear plastic sheet, you won't need an entire sheet. You'll need maybe that much of one. And for the chipboard, again, you won't need an entire sheet. You'll need maybe this much of one. The numbers I gave you are minimums because I like to give myself a little bit extra just in case I mess up a part and need to reprint a sheet to create the part again. To start off with the Papercraft model, you're going to want to download the instructions that include the templates for all the parts that you'll print out. And you'll want to print the first page, the second page, and the third page on that light gray cardstock. Sheet 4 has parts that will be cut from various materials. The fifth sheet of parts are the screen images that you can choose from. And this will be printed on plain white copy paper. We don't want to use cardstock for this because the light needs to be able to pass through this. And the last sheet of parts are the white noise static image, and you want to print this on vellum. If you want to build this like I'm going to build it, where all of the printed lines end up on the inside of the model, and so you don't see any of that on the outside, you just see clean edges of unmarked paper, then you're going to want to pay attention to the direction of the bend lines. A line that's just a regular dash pattern, like you see here, that's going to be a mountain fold. Fold that this direction. And then a line that has a dash dot pattern is a valley fold, so that'll fold this direction with the pattern, the printed side of the pattern facing up. And then that way, that'll give you the lines that we're looking for. So in this case, this edge here is a dash dot pattern. And so that is going to be a valley fold. So that means I fold those this direction. And you need to pay attention to that because especially along these edges where we have this kind of pixelated step pattern all the way around, those bends are going to be alternating directions. And so you've got to pay attention to which direction that's going to go. Another thing to note is there are several pieces in this pattern that have these dashed guidelines. These are not bend lines. Instead, those are just guides to help you locate other parts that have to match up with this. So in this case, this is going to be the base that folds together like that. Essentially, this is going to be the folded version of that piece. Inside of it, it has a spacer or a reinforcement, because essentially we're going to be stacking several pieces all together, and we don't want the weight of them to kind of sag the whole thing down and have it be skewed to one side or the other. So to prevent that, we've got a spacer that goes inside, and I've built that piece here. Now I'm building this piece out of white paper just because when I get the parts together, there are going to be some parts that are internal, like little brackets and reinforcement pieces, that I want those to be able to stand out against the gray so that they're easier to see for you on the video here. So that's the only reason I'm building those out of white. But they also just come off this, you could just print them out of the same gray paper as you're doing the rest of it, and that's just fine. That'll work just fine. This is more just for illustrative purposes. So that reinforcement, this is going to give you an idea of where that reinforcement needs to line up. And for a part like this, that's just an internal structural support, you don't need to be, perfectly on that circle, but it gives you an idea of where that's going to line up, because once we stack all these together, we want all those reinforcements to be on top of each other to give us a nice solid support. This is another one here. This is going to be the back panel, and there's going to be these other pieces that have to line up with that. And so I've given an indication of where that edge needs to line up. You'll also see in the instructions central areas of some parts that need to be cut out and removed, and they'll be marked with an X, like here and here and there. There are a handful of places like that. So when you cut that piece out, you don't need that internal piece, just discard that. Here's another example of a piece that has an internal reinforcement. That's another part of the base. Here's another guideline to install this little piece here. Goes right there. And this main portion of the main box body, this is going to show you again some internal reinforcements, and then those internal guide rails for the board caddy are going to go there. One note I want to make about the glue that I'm using is normally for Papercraft card models that I build, I use a craft glue. I like this clear glue from Aleene's. But there are some bonds where either the bond is going to be really tiny and I know I want it to be strong, not tear away, then I'll use a CA glue or a super glue. Or if there are going to be large flat areas that need to have something glued to them, then I won't use the craft glue. I'll instead make sure I use the CA glue for that. So for this base, there's that circle of reinforcement that's inside there. And if I had used the craft glue, I think it has water in it. And so there's just enough moisture that the paper can absorb that moisture, slightly swell a little bit. And even when the moisture dries off, the paper doesn't necessarily always go back to its original shape. And so for this prototype that I built, you can see on this side, if I hold the light just right, you can see that pattern of where that internal support was glued on there. Basically, all those little bumps are the glue tabs where I attached glue. But on this new one, I used the CA glue. You don't see any, well, maybe there's the slightest little bit of distortion there, but it's obviously much more subtle, not nearly as obvious. And you can see even more egregious examples on this part of the prototype that I built. You can see that. That's pretty bad. I don't like that. So on this side, this is where I glued one of those internal guide rails, and I used the craft glue on this side. Was really disappointed with how much that warped it and how obvious that is. So on the other side, I used the CA glue, and you don't see that hardly at all. So keep those things in mind when you're deciding what type of glue to use on which portions of the model. This piece of the base, the very bottom layer of the base, is a square, and so you don't necessarily need to be concerned about which side is front. You can just pick whichever side looks the best, of all the seams that you glued. And that's going to be true for the other two layers of the base. Piece 17 is going to go directly above that, and then piece 18 is going to go on top of piece 17 up against the bottom of the main box. Up next, I'm going to build the other two pieces of the base. So 17 and 18. And the bottom piece of the base had a piece of reinforcement, so does piece 18. Piece 17 doesn't have any internal reinforcement because essentially I designed the reinforcement in those pieces to be the same diameter as that piece 17 right there. So it directly supports piece 17. So if you're wondering if there should be a reinforcement on piece 17, no, there's not. So assembling this part is probably the trickiest part of this whole thing, just because you have to keep in mind which directions you're folding and which side to put the glue the flaps onto. This is piece 6. I started making it, and one side I built correctly. You can see this is the side that has the lines, the pattern on it. And when I was folding up this side, I built it just right and put the glue flaps on the inside of the model. But then when I got to this side and started gluing things down, I had the glue flaps on the outside of the model. I had to just print out another sheet and redo this part because that was a loss. And it's actually the second time I've done that, because on the prototype that I built, I did the exact same thing. All the other corners were built just fine, except for that one right there. I put the glue flaps on the wrong side. They ended up on the outside of the model. So anyway, I printed a new sheet, rebuilt that. So as you're going through this, just pay attention to those bend line directions. Valley, valley, mountain, valley. And then these ones kind of go back and forth. And they're really short, but you can tell the difference. So you just have to be careful. But that's only half the battle. Getting the bend directions right, that's half of the trouble. The other half of the trouble is when it comes to gluing it on, make sure you glue the flaps on the right side of the model. When it comes time to do the the main box, so these two pieces go, or the four sides of the box here, so all the way around the outside. And I mentioned before that this has got guidelines for where to place parts. These are for the little rails, the centering rails that go on the inside. This inner circle is for one of those structural reinforcements that helps to reinforce this shelf piece that's in here, just so that that doesn't end up crushing. Yeah, you can see where I glued that reinforcement in on this one because I used the I used the craft glue instead of the CA glue on that one. So that goes there, and then this one is actually a guide for where the base is going to glue on. This is the piece that goes to the underside of the box there. It is centered on the bottom of this box. So if you want, you can just, when it comes time to glue that onto your box, you can just eyeball it and get it centered. You could measure and mark if you want. Or I did provide this line as a guide for where this part is going to go. Essentially, I line that up so that this circle, when it goes around, it becomes tangent to the edges right in the center of each of those four edges. It just touches it on this side right in the middle, on this side right in the middle, and then on each of the sides of the circle. But the issue is that this guideline is on the inside of the model. So once you get it together, that circle is going to be in here underneath there, which doesn't really help you to line this up. But it really kind of has to be that way because you can't really print on both this side and this side, right? So I put it there. So if you want, you can transfer a part of that to the other side. One way that I do that is to just use a pin or a needle and just poke a couple of tiny holes. Well, in this case, 4. I would poke a hole at each one of these quadrants. And then when I flip it over, I should see just the tiniest little hole here that once I put this part on, I shouldn't be able to see those holes. And they'll be on the bottom of the box anyway, so not really noticeable. But that's one way to kind of transfer those guidelines over to the other side. Yes, I know, this is probably overkill. It doesn't have to be that precise. You'd probably be just fine eyeballing that. It's definitely overkill. It's just the way I am. So if you're the same way as me, and having something like that be precise is in your nature, then that's one way you can go about it. Okay, I've got the screen frame in place on the front panel. You do have to cut one of the glue flaps back right there to make room for the hole for the power light, because we do need to glue a piece of clear plastic over that. Also, before we move on with this, we do want to cut out the piece of clear colorless plastic that goes here for the screen. So you see there's the clear plastic. It goes immediately behind the frame that we just constructed here. So it glues onto these tabs that are folded back on the inside of the front piece. And for that, I'm going to use a piece of this clear colorless acetate, just a scrap from another project. And to cut it out, I'm just going to take this piece from the part templates, and we've got these two pieces here that represent the ones that have to come out of the clear plastic. That's for the power light cover, and then number 12, this is for the screen, and it's also got a little notch cut out for the power light as well. So the way I do this is I just lay down the template. Since we can see through it, we're just going to take advantage of that, and I'm going to line up. I'm going to just use the two cut edges of the original edges of the sheet, line those up with the edges of the template here, and then I'm going to just put a little bit of pressure on that to hold it in place. And I'm going to I've got a really sharp, fresh hobby knife here, and I'm just going to go through and mark the location by making a tiny little cut with the hobby knife. So right here at the end, just making a little cut there. Do the same thing up here. And it's just at the corner. I'll come back in with a ruler and get that full edge there with the straight edge. I'll mark this edge here. You can kind of see the little corner there. I should be able to line that up with my straight edge and finish cutting it out. Now you don't have to be too precise or too careful about getting really straight lines for this, because you're not going to see the edges of this piece when you're done. Right? It's essentially the edges line up with where these glue flaps end. Those are the extents of that clear piece that we're going to cut out. So you'll never see that once it's in here. You just do want to make sure you don't scuff or scratch the middle portion of your screen while you're working with it. I already cut out the glue flap here to make room for the power light, but I also need to cut out this glue flap right here to make room as well. If you can see that, it overlaps a little bit. And the reason is there's going to be a box that goes in here that is kind of channeling the light for the power light. So I'm just going to use my scissors to just cut it back. Just eyeballing this one, just as long as there's room. Should be fine. Yeah, there we go. Good enough. Okay, now it's time to put in the piece of clear plastic. And I'm more or less just lining up the edges of the plastic with the edges of the glue flaps, since they are sized to be about the same. And the only glue that I've really found that works for this is CA glue, but you do have to be really careful with it. You don't want to get it anywhere near the edges where it can be seen, because if it, smears onto the clear plastic, you're never going to get it off again. And really, what I really want to do is just put it at the very back edge of the glue flaps, so that when I press it together, it doesn't squish the glue out so far that it becomes visible. So I'm just going to run a tiny bead of glue along that back edge. It really just needs to be enough to hold it. Make sure I don't have any on my fingers before I touch the plastic. Done that too many times. Okay, and then line it up. Okay, got that on there. One thing to be careful of is when you're putting that on there and putting pressure on those flaps to get the CA glue to set, you do want to be careful that it's going to squeeze uncured CA glue out at those edges. And so, if you accidentally touch that with your finger and then wipe it across, it's all done. So as soon as it's on there and it seems to be bonded, just set it aside and just let it cure for a while, and don't come back to it until you're sure that CA glue is done. Okay, so I have made a mistake here, and I put this front panel with the window onto the box first before I put the back frame on. That was a mistake. When I built the prototype, I put this on first, and I was able to actually work on the glue flaps that are kind of curled up behind there by just reaching through. This was all open, I hadn't put it in yet. I was able to reach through and make sure those folded under correctly and got glued to the side. But at some point between making the prototype and building my actual box, I forgot that order and I did it wrong. So don't make that same mistake that I did. So the next thing I would recommend putting in would be the little circular support piece that lines up with that guideline there in the middle. And that's going to be this piece right here, piece 9. Okay, got that little support cylinder glued in the middle there. That's good for now. We'll set that aside. And then the next part we want to cut out is this one. This part's a little odd. I just want to make a note that you do cut along, well, first of all, you do cut out that middle square and remove that, discard that, and then cut along that edge and that edge, as well as this diagonal edge and that one there. So when it's done, well, when it's cut out, it'll look like this. Right? So you see where those cut edges are. Same thing over here. And then we just fold it up. And eventually this piece is going to become the frame that goes around the back of the part here. Okay, here's that piece all folded up. You can see got a nice square frame from the front, or well, this is the outside, looking at the back of the box, like that. And then those flaps that were on the inside here, I guess it's actually that way, the inside here are curled up like that. And the one with the flap as a part of the part goes on the top, and the one without a flap goes on the bottom, like that. And then these side flaps just curl under and get glued to the wall here. You sort of see it back in there. The one on the top here, just gets curled under and then glued to the wall like that. And if you haven't made a mistake like I have and put the front panel on with the window first, you would actually be able to get in there and work on those from the front. It'd be a lot easier. But I have obviously made that mistake, and so I'm going to have to just struggle to try and work on that piece with the front all closed up. Okay, quick update on this part. I figured that instead of installing the frame into the back of the box first and then putting this support piece in after the fact, there really wasn't a good way to join up that seam right there with that glue flap. So it's actually better to just do that here with the two pieces out of the box, get those glued up together, and then insert the whole thing. Okay, for this piece here, piece 11, we want to cut that out of black card. And so the easiest way I found to do that is to just cut out the piece from, I just printed this on regular copy paper. There's no need to print that on cardstock or anything. So I cut that out, and also cut out the middle and where the power light hole is going to be, and then taped it onto a piece of black card. This is just some scrap left over from another project, and I just tape it on in a few places so the template doesn't move, and then I'm just going to go along, lay my straight edge down and along the actual edge of the template, and then cut it out. Okay, there it is. So we'll just score that bend line. You do want to make sure that you get that black cardstock screen mask in there first, because it's easier to put that in from the front when it's open than to try and feed it into the back after you've already got the frame. Do make sure you put that black piece in first. You don't have to glue it, just get it in there and then put the front piece on. Glue the front piece down, make sure it's good, and then you can come in from behind and glue the black piece in. Okay, I'm ready to start connecting the front panel to the main box. Oh, and one thing I need to do before I do that is I've got the clear, the smoky clear plastic on for the power light, but then also need to put in this little box that kind of confines the light of the power light itself to that box instead of spreading it around. It just puts it out just right there. So that's piece 14. And again, I've done it out of white just so it stands out against the gray paper. You can just make it out of the gray paper. And there's one other place you have to make a cutout for the power light, and that's just on this flap here. This is going to be the front of my box. So I'm going to drop that in, and then I need to get it lined up. And I think what I'll do is I'll glue down these edges of the box first. So I'll start on this edge, get it lined up. Okay, I've got the black card mask frame that behind the clear plastic. And to put the card in, I just pushed it all the way forward until it hit the frame. I didn't put any glue on the frame itself, with the exception of right there, that little box. I did put some glue on the glue tabs of that, but I didn't bother to put glue on the actual clear plastic that the black card is up against. Instead, I just glued the flaps of the black card to the outside, well, the inside of the outer box. So you can kind of see a little bit there where there's some glue residue. Some glue residue right there. That's from me just, I didn't have a whole lot of room to work it in there, so I just got a little bit of glue on my tool here and then just kind of applied it across that. And I just did one flap at a time, put the glue on, pressed down. I set the box so the side I was gluing was against the table, and then just put some pressure on it to make sure that it bonded. Waited for a little while, moved on to the next one. I finished piece 25. That's this little tab that goes in here. And there are some guidelines in the shape of a rectangle on this piece here to show you where that goes. Just note the orientation that's been glued on. Essentially the right angle of that triangle is against this plane and facing forward, if that makes sense. I've also started on the back panel. This is piece 20. I've cut out the little rectangle there, and then this dashed rectangle around the border is a guideline for where to install. These are pieces 22. They're both piece 22. There's two of those. Let's see where I've cut them out there. They're identical, and they get glued together like that. And then on the opposite corner, same thing. You want to put those glue flaps on the inside because this outside face is what kind of keeps the back panel in place as it slides into the back like that. And then I've cut out a notch in this glue tab here. You can see it right there. These assembled pieces 22 are going to glue to the back of piece 20, and we don't want that glue flap. If you don't cut a notch, the glue flap will overlap the hole for the switch right there. So you want to cut that out, and then once you've glued these two together, line them up on the guidelines around the edge. And then for the final piece of the back panel is the little box that is going to contain the switch. This is piece 21, and I've folded it the opposite of what the instructions show because I wanted to illustrate how this piece goes together. It's not very intuitive. First of all, you do want these large glue flaps around the edge. These ones here you want them to go outward because this is going to glue against the face, and the inside of this rectangle that you're going to make like that, that's where the switch is going to go. So I've got, this is my toggle switch, and this is just a little slide toggle switch. This model is designed to fit a toggle switch of these particular dimensions. So you'll want to find something of the same size. And it's 8 millimeters in the long direction, just shy of 4 millimeters in that direction, and that's about 3.5 millimeters in that direction. These are very common components, so you should be able to find a switch of that size. The switch is going to fit inside that rectangle there, this direction, and these glue flaps here that you see are going to glue to the back of piece 20 of the back panel, and then the actual toggle part of the switch is going to go through that hole like that. Because the switch needs to fit on the inside of this box, we want to make sure that all of the glue flaps for creating this box go on the outside of the box. Normally when you're building a box like this, you'd want to put the glue flaps on the inside so that they are not seen. But for this piece, we want them on the outside so that they don't interfere with being able to fit the switch in there correctly. And one final note on this piece here is that I've got this series of lines here that I have not yet cut out, so the intention is those need to be cut out to make room for the leads, the electrical connections on this switch to pass through. Okay, in case that was not clear, I've just used a pen to color in red all the parts that are going to be cut away from this part. Then that will leave a blank space for those electrical connections to come through. Okay, I've removed those 3 red sections. So now you see what we've got there. Those are going to be the glue tabs, and you'll see that here in a second. But I didn't really bother cutting those into the triangular shape just because they don't really need to be, and this gives me just a little bit more surface area to glue to. Okay, so there it is, glued in the box shape. There's the switch installed, and these tabs on the back will bend over, and then the glue flap will go around the outside and glue down. Like that, etc. So the way I've designed this, you could install the switch in here, glue it into place, but then you've got to actually get the wires for the switch to the board and solder those wires on there. And you could do that with the bracket or with the switch in place already glued into the bracket, but you don't have to. You could solder the wires to the switch and then install the switch into the bracket and then fold those pieces of paper over, those tabs over, and glue it into place there with the wires already soldered in place. So that's the idea with these odd little fingers of paper as part of this design. So I'm going to actually glue this whole back panel together. I'm going to put this assembled piece on, and then I'm going to put the bracket in place and just leave these fingers unglued until I've got the switch ready to install. Okay, here's what the back panel looks like assembled. And there's piece 21 with the finger flaps not glued down yet. The back panel is good. Now you should be able to do a test fit on the box. And it should be a nice snug fit, but not too snug, hopefully. If you need to get it off, just pop it out like that. Alright, so the slide is actually made up of 5 layers of material. The first outer layer that you see here is the black cardstock mask. The second layer is the white noise image printed on vellum. Third is the actual screen image that you want to display, printed on white copy paper. The fourth, I'm going to flip this around so you can see it, is a sheet of clear plastic. And the fifth and final layer is this frame made out of a heavy card. I'm going to go into a little more detail on each layer and why it is the way it is and how you make it. Okay, that first layer of the slide is going to be out of this black cardstock. So I've got some just scrap black cardstock here, and we are going to want to cut that using piece 23 from our template. The second layer is our white noise screen image, and that needs to be printed on vellum. When you're going to cut this out is you want to cut this outer edge is your cut line. Okay, so the blank space between the outer edge and the actual screen image, that's not going to be seen, but that's the part where we're going to put our glue. So want to make sure you don't cut on the inside, you cut on the outside. And actually that edge that you're cutting on is not going to be seen, so you don't even have to be all that careful with it. You can just freehand it. Okay, there's layer 2. Layer 3 is the actual screen image itself, and you get to choose from all of these various screen images here. And as you can see, I've pulled images from Sonic 1, the first Sonic game, and then images from Sonic 2. As the item boxes are the same size, but the screen images are slightly different, so I wanted to give you a choice what to choose. Most of the differences are just in the color of the images, but there are a few pixel differences, and that mostly shows up in the image of Sonic himself, where in Sonic 1 he's a little more basic. In Sonic 2 he's got just a little bit more shading on his face. He's got a highlight on his pupil where he doesn't in Sonic 1, and around his chin he's just got a little bit more shading. So the rest of the images, obviously Sonic 2 has tails, but the other images are pretty much the same in the pixels. The differences are in the colors. So for Sonic 1, you can see on the ring, it has more of a copper color on the inside, but for Sonic 2, it's just more of a dark yellow. And for the stars, they're just a darker, more vivid blue in Sonic 2, where they're kind of a lighter blue in Sonic 1. Same kind of blue differences on the shield bubble. And then for the shoe, the only difference really is in the border. In Sonic 2, it's a little more of an orange, dark yellow color. But for Sonic 1, all the borders are this like brighter yellow. So anyway, subtle differences, but I figured might as well give you the choice. You can choose what you like to build. And again, the important thing here is you want to cut around the outer edge of the rectangle, not the inner edge. The inner edge is there to help us align everything once we put all the layers together, so we can get the screen image to be straight and centered. But the outer box is what we cut. And again, that edge is going to be hidden, so I can just freehand it, or you could use scissors. Okay, there's layer 3, screen image. Okay, layer 4 is the layer of clear plastic. The purpose of this layer is really just to provide support for the 2 layers of paper that are the screen image and the white noise image. Now it needs to be the same size as the screen image, so I'm just going to use where I cut out the screen image from this sheet as a guide for marking the size of this clear plastic piece. Okay, there's layer 4. Okay, layer 5 is made out of extra thick card. So this, you're going to want to use something that's stiffer than what you're using for the card for the box itself, and even thicker than what you've got for the black card. So I recommend using something like chipboard, which is, decently thick stuff. Or like what I did here, I just found some thick card from a cardboard package. So something like this. I've got this little box left over from something, and it's just a thicker card material. To cut this piece, you're going to use piece 24 as a template. There's layer 5. Okay, for assembling the slide, I suggest taking the two screen image layers and gluing them together, lining up their cut edges, and also, more importantly, that inner rectangle of the screen itself, just in case your outer edges are a little sloppy. And then I would glue those two layers together. Just using a little bit of craft glue would be fine. Just don't do so much that it blobs over into the actual screen, the visible screen area. Then once those two are bonded together, then I would get the front black cardstock frame and then glue it to those two layers, making sure that you line up the inner rectangles again. And just use craft glue for that again. Then once you give those a little bit of time to dry, then you can flip it over, glue the clear plastic on the back, and you can just line up. It's going to be the same size as the outer edges of the screen layers, so you could just line those up. It doesn't have to be perfect. Those edges are not going to be visible once it's all glued together, but you do want to make sure you leave yourself enough room around the clear plastic so that we can glue the final layer on. So you add a little bit of glue to the exposed area on the back of the black cardstock, and then you put on the back layer, and then you'll have to pinch those together. You're essentially gluing paper to paper, encapsulating the clear plastic and all the screen layers. You can be a little more robust with the gluing around that edge, because none of that edge is going to be visible. You do want to make sure you have a good bond that's gluing back layer to the front layer really well so that it all stays together. And then once that's done, you can rinse and repeat for any other screens you might want to add to your box so that you can swap them in and out. And there's our completed slide. One suggestion that I have when you're building this is, once you've got the two screen images glued to the front black cardstock frame, you don't really need to glue the clear piece of plastic to those, because once we glue the front frame to the back frame, that'll just sandwich in that piece of clear plastic and it's fine. That'll hold it in. But I did end up putting a little bit of super glue just on the very corners of the clear plastic, just to kind of tack it down and keep it from sliding around while I positioned the back frame on. And that was very helpful. So just a little bit of super glue on each corner, and that was very helpful. For gluing the final frame on, I just slathered a bunch of craft glue around the exposed edges of the black card, positioned the back frame on there, and pushed it down, held it enough until it started to dry a little bit, and then I flipped it over, and then I used my pick tool here, press it down against the table just to make sure it formed a nice good bond there. And you can kind of see where I ran the tool along, it made the paper a little bit shiny, which is fine because this part's not going to be seen. Just makes like a little ravioli, I guess. And when it comes time to install that in the board caddy, we just drop it in between those slots there. at the top, and then same thing at the bottom. There's a pair of slots down at the bottom, and they just hold the corners of the slide. And there we go. There's our box with the screen image in place. Now all we have left to do is set up the electronics. Let's talk about the electronics. Here's the schematic for the circuit. If you want to build your own version of this circuit on a prototype board, then it'll be handy to have this schematic as a reference. But if you're going to build the circuit with the printed circuit board design that I've made, then you won't necessarily need to refer to this. Another thing that will be helpful if you're building it on a prototype board will be the trace diagrams. So this is what I did to lay out the actual printed circuit board, but it's also going to give you an idea of where the components could be laid out on the prototype board, because again, the printed circuit board is the same length and width as a 5x7 prototype board. So you should be able to lay the components out in pretty much the same layout, and you could just run the wires according to more or less to what I've done with the traces here. This is the back of the board, essentially what's facing out the back of the item box. And then this is the front of the board where you will install the LEDs that'll face towards the screen, the front of the item box. And you certainly don't have to lay your wires out just like that, but this should be helpful to give you an idea of which components need to connect with which. I've also got a list of components that you're going to need for this build, and this list here is the list of all the components you'll need to actually install on the board, and we'll talk about each of those. And then there's also a list of components you'll need that are not on the board. So it's going to be your battery, your power switch, your power light, etc. I have got the printed version of my circuit. So it's got some outlines for where components go with their labels, as well as some instructions for which sides the LEDs go on. So this one specifically says install LEDs other side, so not on this side. So even though there are little lines indicating a component there, it does not get installed on this side. It needs to go on the other side. All the other components, except for those LEDs, go on this side. And if we flip that over, you'll see install LEDs this side. And I guess the only other components on this side are the resistors for those LEDs. So don't forget those components. So I've got all the components that I'm going to need to put on my board here laid out on my breadboard. And I'll just go through those, what you're going to need to show you what that looks like, and then where it's going to go on the board. So the first are these optional connectors. And these are components that look like this. And they're going to go on these rectangles for filament 1, filament 2, battery, switch, and then down here for power LED. And they just plug in like that, solder them on the back. And then these connectors allow you to have another connector of this type, which is the mating end, and that plugs in like so, and allows you to quickly connect and disconnect components from the board. These connectors are optional. You don't need to have them. You could just solder the wires directly to the pads on the board. But they are nice, and I wanted to build in the capacity to add those for convenience if you wanted. Second item on the list is the capacitor. Electrolytic capacitor, 22 microfarad polarized. And that's going to be this guy. Here's what I've got. So 22 microfarads. This one's a 50 volt rating, and then it's electrolytic, so it's polarized, which means the direction you install it matters. And that's going to go right here in this circle on the board. There's 22 microfarad. And then this is the hole, the positive hole. So on the capacitors are usually marked with the negative side. Like you see that white band on there marked with negative. So that would go like this with that negative there. I'll have to trim and adjust my leads to get all these to fit the board, but that's the idea. Make sure that is important. Next on the list is going to be our 3mm white LEDs. There's 12 of those. Here's your standard 3mm LED. And again, polarity matters on these. I'll install the correct direction. So in this case, where I've bent the positive wire, that's going to end up being on the left side there. And then of course I'll have to trim and adjust those leads to actually fit in the holes, but that's the idea. All right, next up on the list, we've got some more of the connectors for the filament LEDs. Those are the ones that go here. So there's filament 1, right side of the board, filament 2 on the left side of the board. And these are going to go out to the actual filament, LED filaments on either side of the board caddy. Those are going to be the filament LEDs that get installed on either side of the screen here on the board caddy. So we'll have wires coming back from those filaments back to the board. And again, you can either solder them directly to the board with noting the positive side here, or you can use the connectors. All right, up next we've got the star of the show, the timer chip, 555 timer in a dual inline package. So that's on my breadboard still right here, that black rectangle with the 8 pins, and that's going to be installed right here. And pin 1 on the chip is marked with that white dot right there, so it goes through that hole. And on your, let me go ahead and pull this out. So here's the 555 timer that I've got. And your integrated circuit chips are going to be marked on one end. In this case, there's a little divot, a little cutout, kind of hard to see. There you go, right there. That's marking basically the top of the chip, so the pin 1 is going to be the one on the left of that. So that's that guy right there. That's pin 1. So that'll just slot into the board like that. Okay, up next is another connector. This one's for the power LED. That's going to connect in right here, down at the bottom of the board. Power LED, positive side. And then that's going to run wires out to the red LED that's going to get installed right here. Up next, we've got our PNP transistor. The 2N3906 is what I'm using. TO92 is the package type, and then I've laid it out on the board as collector base emitter, which you'll see here. That transistor goes right there. PNP. So it's laid out as collector base emitter. And on the breadboard, here's the one I've got. 2N3906. Up next is the other transistor, which is an NPN, 2N3904, also TO92 package, and this one's EBC, or emitter-based collector. And that one's going to go here. So there's NPN, emitter-based collector. And then on my breadboard, that's this guy right here. Pull that out, we can take a look at it. Okay, that one's really hard to read, but there's 2N3904. Okay, the rest of the components, except, well, we'll skip to the last here. So that's going to just be another one of those connectors. And this is for the switch. And that's just up towards the top here. Switch. In this case, I didn't mark a positive because it's a switch. That's not relevant. Okay, so the rest of the components on here are going to be all of our different resistors. They're all just listed as resistor axial, but their values are over here. So we've got 10K, a couple of 10Ks, 47, etc. And then as for where they go on the board, they are all marked on the board what they're supposed to be. Okay, so that's all of the components that are on the board. Now, there are a few components you're going to need that are not part of the board, but they're part of the circuit. Here's a list of components that are not on the board. First on the list is the battery. You're going to need a 9-volt battery. Okay. Next, you'll want a connector clip for that type of battery. So that's going to be one of these. Up next is a slide toggle switch. And then there's some specs for you on the kind that I've got. Okay. Just one of these little slide toggle switches. Next up, we've got a filament LED. Used to be a 3-volt DC filament. Cool white color. The kind I have is, that goes with 3 volts is 100 milliamps and 38 millimeter length. And then there's the approximate brightness value for the kind that I'm using. So that's these guys. Those are my 2 filaments that I'm going to use. Also got one more LED, another 3 millimeter LED, but this time it's going to be red, not white. So it'll look just exactly like this. This is a white one, but it'll put out red light instead. In fact, on my breadboard, that's this guy right here, but I'm going to leave him right there so I don't accidentally mix him in with my whites. And then for hooking everything up, you're going to want some wires for connecting to the battery, to the switch, the power light, and to the filament LEDs. And then optional, we're going to be the other ends of those connectors. So we want the plugs for those connectors that are on the board. If you're using the connectors on the board, you'll need the plugs. That's these guys. And you can either get those in a pack like this, where it comes with both the female connector and the male plug. I just noticed that they labeled those opposite. So yeah, so this is the female housing, and that's the male plug. And then you have to have a crimp tool to get the little pins into the male plugs to crimp onto the wire and then insert it into the male plug. Or you can get them in packs like this where they come pre-wired. That's probably the easiest way to go. Then you don't need a special tool for crimping the little pins onto the wires. Okay, so that's everything you're going to need to build this. Let's go ahead and start putting the board together. Okay, I'm going to start by soldering the components on the front of the board here. So that's going to be our 12 white LEDs and the 4 10 ohm resistors that go with them. Before you solder your LEDs to the board, you're going to want to test them. So you can do something like this with just an LED tester, or even just like a coin cell battery, a 3 volt coin cell battery. You can just touch the leads to both sides and see if it lights. Of course, you got to make sure you got your polarity right, of course, but also just you want to make sure that your LEDs are actually working before you get them in the board and have to take them out later. Okay, you're going to want to install them all just like that. Make sure you flow enough solder into the hole so that it makes a good connection and that it's flush on the top. Okay, I've got all the LEDs on the board, plus the 10 ohm resistors that go with those. So that's everything on the front side. Okay, so we're going to do the other side now. And I think I'm going to start with the integrated circuit, get that in place. Okay, up next I'm going to go ahead and put all of the resistors on this side of the board, since they're kind of the lowest laying components. it's easier to put those on first and kind of work our way up to the tallest components last. Okay, got all my resistors on the back of the board, and I started with the NPN transistor, got that in place. Now it's time for the PNP transistor, and I've got it marked which holes are for the collector and the base and the emitter, and the printed on representation kind of shows the flat side here, but I know that my transistors are not CBE, and so if I were to install with the flat side on the same side like that, it would be wrong. Mine are actually EBC, so I've actually got to turn this around, do flat side the other way, and that'll line up. So it's annoying when they don't mark the transistor, so you don't know for sure. I did have to just do a little bit of testing to find that and look up some data sheets until I was sure that that's how these were. So just be sure what yours are before you install them. Okay, next up, we'll get the capacitor on there. Want to make sure we note which side is marked negative. In this case, it's going to be this lead right here, which happens to be the shorter lead. And then this hole is marked positive, so that positive plus there goes with that hole. That's indicating that hole is positive. Okay, there we go. And that's all of the necessary components for the circuit to function. All I have left to do for mine is I'm going to put those optional connectors on. So I've got these pre-wired plug half of the connector, and I'm just noting which color is the red wire, which side that's on, and when I plug it in to the connector, which side that's going to be on, so that I can make sure that I orient these connectors the right direction. Okay, the board is built. Now I just need to test it, and hopefully everything works. I have to test whether all my connections are right. I put the components in the right way and in the right place. Okay, so I tested this by dropping the board into the Caddy and then dropping the screen image slide in. And that's a little hard to see. There we go. It's a little bit spotty, the light. You can tell there's bright spots directly where the LEDs are. It's more of a problem with this one than it was with my original one, just I think because it's slightly scaled up and the spacing between those LEDs is a little bit bigger. But also, I do remember that on the original prototype, I had gone through and sanded the tips of these LEDs to scuff them up a little bit, just to help scatter their light a little more, instead of having them being more like straight, narrow beams coming out, which is really, this type of lens on these LEDs is designed to do that, to kind of focus the light into a narrow beam. And by sanding those off, it tends to just diffuse the light a little bit more. So I'm going to go ahead and try that and see how much that affects it. I don't know if you can see on the back one here, I've started a little, you can kind of see that it's just a little bit more diffuse, scuffed up there. So I'm going to do that with the rest of these and see how it does. But I did also sand the tips of these LEDs, like I said, to help diffuse their projected light onto the back of the screen image, so it doesn't look quite as spotty as it was before. Yeah, I think it looks a lot better than it did. I've designed some holes into the board caddy for wires to pass through for the filaments, and then the wires travel behind where the screen slide would be, which is this slot here. That's where the screen slide is, and then this slot here is where the board is, the circuit board. So then you run the wires underneath the circuit board and then out to the connectors on the back. My initial design was to have the wires travel on the outside of the board caddy and then come around to the back of the board. But that didn't work. It was just too much bulk. There wasn't enough clearance for the board caddy to actually slide into the box. So it's got to go through those holes and then under the board. And then for attaching the filaments to the board caddy, there are a couple of grooves in the 3D printed model that indicate right where that filament's supposed to go on this side, and then the same thing on the other side. You can sort of see the start of the groove where it dips down there and then dips back up right there. So that's where the filament goes. And again, you just want to make sure it's not sticking too far out to the side. There's a little bit of clearance, but not much. So run your wires through the hole, solder them to the tabs of the filament on top and bottom, and then put on gobs of hot glue to fix the filament on each end. I also put a few gobs of glue just to keep the wires from lifting the board up, just fixing them to the floor of the board caddy. And then for the power LED, it gets installed inside the bracket. The bracket will either be on this side or on this side, depending on whether you're doing a Sonic 1 or Sonic 2 box. Sonic 1 box has the power bracket on this side. Sonic 2 box has the power bracket on this side. And then there's just a hole that the LED goes into. Just put a gob of hot glue to hold that LED in place after you've soldered the wires to it. And then the wire goes up through the hole, either here or there's a place you can cut the hole through the board on that side if you're doing the Sonic 1 box. The filament LEDs come with these little straight tabs off the end. And when I soldered them on, I bent the tabs so that they would be going backwards. But you really have to be careful with working with these because these filaments are very fragile. They break very easily. In fact, in bending one of them, I did end up breaking it. They're made up of just like a thin stick of plastic that the diodes are mounted onto, and the plastic is brittle. So yeah, just trying to bend those tabs was enough to crack that, and then it eventually just broke off. So now, having done that and broken one of these things, I would recommend don't even try and bend the tabs. Instead, just bring in the wire and have it come across like that and solder it in place like that instead. One final note is you might be able to see it. Yeah, you can see it through there. There's some light bleeding through the side from those side lights. They're essentially right up against that paper, and you can see it bleeding through. You can see it a tiny bit on the top, but honestly that's really not very noticeable. So what I recommend is down inside, just putting a piece of black paper that just covers about that much of the side on both sides, and that should be enough to block it. Okay, there's the plastic panel on the side there, and then the other one on the side here. If you're going to 3D print the box, then these are the parts you're going to want to print out. Got the main box itself, the back panel, the stand, the very base of the stand. This is the part that goes between the bottom of the box and onto the stand, like that. And then the front bezel. And there are two versions of the front bezel. This is the one for Sonic 2, where it has the power light on this side and these little tiny details that are recessed in. There's also a version for Sonic 1 that I haven't printed, but it will not have these recessed details and it'll have the power light on the opposite side. Other than that, it's identical. And then if you're going to light it with the blinking electronics, then you'll want the board Caddy, and then the bracket for the power light that installs on the bottom of the board Caddy. For the best results, I would print this out of gray filament if you have it. If you don't have gray, you can print it out of whatever you've got, but you'll probably want to paint it gray once you've got it done. If you're going to be doing the lighting effects with the lighting board on the inside, you'll want to do something about blocking the light from coming through the walls. If you've got gray filament, it might be good enough. It might block enough of the light that it's fine. Although these walls are pretty thin, so I don't know if even that would be enough with gray. So you might still have to do some light blocking even with gray. I'm not sure. The next best choice for printing would probably be black, because that way I think that would probably block most, if not all, of the light. Then you can just paint the outside gray. Probably the worst option is white, which is what I've done here, simply because the only color of filament that I have is white, so that was my only choice. There are a few parts you're going to need that are not 3D printed. First of all, you're going to want something for the screen image, and if you're going to do the staticky blinky effect, then you're going to want to build one of these screen image slides. So for all the non-3D printed parts, you're going to want to look to this sheet. This sheet can be found inside the file that has all the parts and instructions for the Papercraft version of the box. And you'll want to just print out this page on plain copy paper. It has templates for all the parts you're going to need to make. First is this part here, which is a template for cutting out the clear plastic for the screen. And you'll want to cut that out of just some clear sheet of plastic, something like this scrap that I have. This is just a clear transparency sheet, or sometimes it's called acetate, like craft acetate sheets. If you don't have something like this, you can usually find product packages that'll have this kind of thin plastic. Like this right here is the window on a Funko Pop box that I just ripped out. You can see it's got where it was glued into the box here, or any other kind of thin plastic sheet for you can find in product packaging. This is a template for another part you're going to need that you're going to want to cut out of black card. And that ends up being the black border that's around the screen image just behind the clear plastic sheet. And again, you're going to want to cut that out of black card like this that I've got here. For instructions on this part, refer to the section about building the paper model. The screen image slide is the same whether you're doing the 3D printed version or the Papercraft version. Once you've cut out the clear plastic and the black mask, those are going to be installed on the back. This is the Sonic 2 version of the box, so this is the front. So you flip it over, line up this notch down here at the bottom. That notch is there to give clearance for the power light cutout. So you glue the clear plastic onto the back like that, just using some CA glue, and just put enough around the edge to glue it on without squeezing any out into the visible portion. And then you can just more or less center this by eye. Okay, I've got that on there. Honestly, I did way more glue than I really needed to. I could have gotten away with just putting a dot of glue in each corner. Once the clear plastic is on, then you want to glue the black card mask behind that. For the black card mask, I recommend doing the same thing, just put a spot of CA glue on each of the 4 corners. And this one, you do want to be a little bit more careful about the positioning of this, because you want to make sure that when viewed from the front, that mask is going to be more or less centered, right? So I've extended the mask out to encompass the power light cutout, and that should serve as a guide for helping you position that. Okay, there it is, with just spots of glue at each corner. It's holding on there just fine. You need to install the clear plastic and the black card mask before you install the front bezel on the front of the box, because you won't be able to glue it once that's together. The 3D printed circuit board Caddy comes in 2 parts, the Caddy itself and then this little power light bracket. Depending on whether you're building the box for Sonic 1 or Sonic 2 determines which side the power light is going to be on. For Sonic 1, the power light is on this side of the box. For Sonic 2, it's on this side of the box. I've designed the board Caddy to allow you to place the power light bracket on either side. At the front of the board Caddy, down at the bottom, there's a notch for where the power bracket goes, and there's one on either side. This notch is designed to interface with the power bracket like that. The notch helps you locate the power bracket so that it's in the correct place horizontally. So you just put a little bit of CA glue on the power bracket, drop it in place so that it lines up with the notch. This side for Sonic 1, this side for Sonic 2. Okay, here's my finished 3D printed version of the Sonic box. For the paint, I ended up using this automotive primer, but it's like the filler type, or also known as like a high build primer. And I chose that because I didn't really want to do a lot of sanding to remove the layer lines on these 3D printed parts. I just wanted something kind of quick and dirty, and it did a pretty good job. I mean, you really can't see the layer lines in this video unless, if I get up really close, then you can see little bits of them. And I probably could have maybe done just a little bit of sanding after I primed it, but for the most part, it's pretty good. So, and then for this little recess detail here, I just hand painted that with a darker gray. And for final assembly, I put together the 3D printed parts with CA glue, super glue, crazy glue. So there it is. That's how you build the 3D printed version of this thing. If you end up building this or the Papercraft version of the box, then I'd really like to know. So just leave me a comment. Tell me how it went. Thanks for watching.